Hey, Rania, you see all the people? We're, we're getting ready to start. So we're going to do an introduction, a couple minutes, and then you're up.
Okay, thank you.
Yep. All right, Rania, welcome. You have, 30 people in the room. So, everybody, let's wave to Rania. Oh, no. Oh, no. Is it working now?
No. Well, it doesn't look like she waved back.
You did wave back. Do you see us moving or not?
No.
And you're on mute. No.
No, I don't see you moving.
Uh-oh. Technical problems.
Not again.
Not again.
It just worked. Technical problem. Never solved it. Worse than my Kubernetes pickup. Never happened.
Good. Just speak up wide. Of course they will be good.
Let's see if this works now.
Yeah.
Hey. Now we need to just hear you again.
Can you hear me or no?
Oh, no. Yeah.
Oh my God.
Okay.
There we are. Okay, I'm gonna turn up the volume. And you have to mute us, you or she gets feedback. All right, so let's double check if everything is working. I think so.
Hello?
Rania, the floor is all
Hello,
yours. Yes,
Okay.
we can hear you. Awesome. So we're going to
Okay.
make it a little awkward by muting ourselves. Otherwise, you get your own voice back and feedback. We don't want that, but I'll be monitoring. If there's anything, I'll be back. Have fun,
Okay.
and we'll be here listening. We promise.
Thank you. So today we are going to, I'm going to talk about really SRE and how SRE can really help in implementing, or actually it's an implementation of DevOps, and it's really transforming DevOps and DevSecOps. So just a quick brief about myself. My name is Rania Mohamed. I'm a cloud architect in Google. I have passion since college in Java and SOA. I also have passion for cloud and microservices and cloud native architecture, as well as service meshing concepts and methodologies. So I'm going to start by what is the problem that we are trying to really solve there in the software delivery in general. So the majority or the cost or the biggest concern in the software delivery is not in writing code or even designing the solution itself, or in developing the database or analytics. The majority in the software cost itself is really in the maintenance and in operating the software itself after the launch. And this is because of a lot of concerns or a lot of conflicts that we have between different stakeholders or different teams that are involved in the software delivery. So again, it's all about alignment, and mainly because the core stakeholders that we have who are building the software or the services are developers, and the ones that are really operating and maintaining the software is the operators. So we want to really, again, bring the two angles together, and because they have different concerns and different targets or requirements, like developers, they want to be free and agile to really innovate and write code and focus on their building their services and delivering or using even new framework. While the operators, they want to be stable, have the production stable and all the environment stable. So they have different concerns. I want to really start setting the scene by really talking a little bit about the stakeholders, the different stakeholders, because I see that sometimes we have confusion on really IAC versus DevOps versus DevSecOps, and what are really the angles that we have there. And that's why I wanted to really just potentially touch point about what are the different stakeholders in the DevOps era. Again, we have the developers, we have network team, security team, as well as the product team, and it can even add to that, but those are the really main stakeholders. In the stakeholders, definitely we have different concerns and different requirements. Like the network team, they are focusing on the infrastructure, on the governance of the network and the structure and who has access to the network itself and the topology of the network. While if we are talking about security, they will be really concerned with the auditing, more concerned with the sign-off and making sure that none of the processes or the services that get really promoted to a specific environment except after really approvals and sign off. While, for example, if we're talking about developers, they are more focusing on debugging capabilities, even in production, autonomy. They don't care about the whole world. They care about really and focus on their code and the new framework. Sandbox environments, they don't want to really wait for ages in order to build something or to test something or dry run something. And as you can see, again, developers tend more towards, I don't want to be controlled, so I don't want to have any governance, while really, if we go to the security team, they want to control and micromanage everything. And the same, the network is in the middle, the network team or the infra team is in the middle between both. So if we go to really talk about that those are silos, yes, today it's a problem. Those are silos, and we can bring them together using the DevOps and using the automation and using SRE as well. Just to give the consensus there, the developers are mainly focusing on the DevOps tools, okay, because we are talking, or the pipeline or the process, because there we are talking about really building from the code, building images or whatever, the code itself or the artifact. We're talking about testing the artifact itself. So we are focusing on the development story and the operability story from a development aspect, while the security is more focusing on the DevSecOps and the network team is more focusing on the infrastructure as a code. And yes, we can definitely bring all together by really automating tools and by the SRE and by the different principles that can really help them deliver stakeholder deliver their targets without really learning the language of the other team, because this is the obstacle that we have today, that we are trying to ask the developers, please learn to speak in the security or in the IAC language. And this is something that is super hard for developers. So just like the friction, as I was saying, there is a friction between the business and the development, and there is a friction between the development and the operation. Actually, the DevOps and the DevSecOps was really focusing on this, while I'm going to show how SRE is really helping the three alignments, the business, development, as well as operation, to really deliver things without really friction, and even deliver the shift left approach that we consider heavily within Google for the SRE implementation. So I'm going to start about really the basic, simple definition for DevOps. So again, it's a set of practices and guidelines and culture that is designed and meant to really break down the silos so that we don't have silos between the different teams, as I showed earlier, the architects and the security and the infra and the networking and the developers and even the testers and the product team. If we go to the key areas that we are focusing usually on in the DevOps, they are more into reducing the silos, okay? More into accepting the failure as a normal. And this is one of the biggest principles that SRE is aiming and implementing for, that we have to accept failure. It's okay to fail, but we need to have a plan how to really handle the failure in a normal state. Implement gradual changes, and I'm going to talk about really implementation to the gradual changes. It's not really only about agile, it's about as well how can we use live data, whether it's a config as data or policy as data, in order to really enforce that we are not really moving forward with bigger problems, okay? So it's not about really release planning, and it's not about game planning. It's more about really implementing the proper pace based on your production reliability. And also leverage definitely tooling and automation. So those are the 5 key areas that are considered whenever we are talking about DevOps. And last but not least, the measure everything, which we were talking here about really matrices. And the matrix here is, as I'm going to show in a couple of minutes here, it's heavily related to SRE, because SRE is all about really live data, about what data we are capturing from production and what really matrix we are reading and self-reading and self-actioning upon it. So what's SRE? SRE, it's site reliability engineering. So SRE, the site is more into what do we want to really focus on, what we are trying to really engineer or operate or build even and deliver. Reliability, why do we need it? Why do we need the whole principles, and engineering, how will we implement it. So SRE is more to really talk about, I have a site or I have an artifact, I want to make it more reliable, and this is how I'm gonna do it. But the measures will differ, and the artifact itself will differ from one customer to another and from one implementation to another. So again, it's then the main principle of the SRE, and this is the modern even implementation of DevOps, even regarding the KRM and other methodologies within the implementations of DevOps. It's that it is always driven by data. So it's always driven by facts, by real things that I'm really capturing live from the system. And that's why we are talking about here that SRE, it's mainly about using the data to drive the decision that you are making, okay? It's not about really using theoretical figures or theoretical requirements or even theoretical planning. No, I want to really leverage live data, what is already into the system, okay? And based on that, make my own decisions and even implement those decisions in an automatic manner so that we can implement like a self-healing or a self-scaling or a self-reliable system and more intelligent system that can really implement and deliver my DevOps principles. The biggest principle and focus within SRE is that we are not really splitting operation or splitting the people who are doing operating from the engineers. So they are part of the software engineer, and they are really dealt with in the same manner and the same priority as developers and as testers and as architects and as product managers. They are not really isolated from the whole software delivery process. Again, it's not about really building or designing or assigning the operation and the maintenance for the sysadmins. This is not the thing. And DevOps engineers, it's not really meant to be sysadmin engineers. It's more, those are, again, software engineers. Again, they are really motivated and they are capable of writing automated code and automated software. They are involved into the design and the architecture of the software itself. So they are focusing on the reliability, the operability, the non-functional requirements from a maintenance and operation aspect, so that it makes sense that again, whenever we have the software ready to go to production, we will not really face problems in operation or face problems or risks while really having a load on the system or even facing any failure on the system. So the SRE team, it's definitely part of the team, as I mentioned. It's not really isolated. They are not really sysadmins, and again, they are software engineers, okay, but they are more focusing on the area of the SRE. They are definitely focusing on the non-functional requirements like scalability, reliability, efficiency. And again, as I mentioned, that's why they are heavily involved in the design, in the architecture phase, and also they are into the story of building automation software and innovative ideas there. They are definitely helping with the intersection of the system engineers and the software engineers, so that it's not meant there that the system engineers would be only focusing on call or even on fixing bugs, okay, or rebooting the system. This is not the idea, or even building or releasing a release or an agile release or promoting it into production. No, they are part of the team, and that's why they are aiming as a balance or as an intersection between the software engineers and the system engineers. So again, things here that we are aiming for via the SRE team is that they are making production better. It's not really by rebooting the system. No, they are definitely using engineering approach, and that's why they are involved more into the architecture. And the most important thing, as I mentioned, that they are always planning for the worst. They are always planning for the failure and for the acceptance of the failure itself on the architecture phase, in the design phase, as well as in the promotion or the deployment phase, or the runtime and the operational phase as well. So you can think of SRE as a class, as an implementation class for the interface of the DevOps, okay? SRE is definitely animating all the practices that we were aiming for into DevOps, which are the guidelines and the practices for the designing and the breaking down of the silos that we have in the software delivery. The 5 key principles, they are the same 5 key principles that we have in the DevOps, but I'm gonna show how SRE is really helping with those 5 keys principles and delivering them out of the box, and even innovating and transforming in the implementation of DevOps and DevSecOps. So we have 3 main principles, okay, for SRE. And the first principle is service level agreement, defining the service level agreement, service level objective, as well as its consequences of not meeting such an SLO. And I'm going to talk about the definition with example for the SLO, and really speak about how that is measured within DevOps and DevSecOps. The second one is that SRE is meant to make tomorrow better, always, and to make everybody happy. And that's why we need to plan and to have time to make things better. And it's not only business, it's operability, it's everything. It's scalability, resiliency, it's efficiency, and everything with respect to the non-functional requirement that we are implementing within our system. And also, the SRE team, they are not meant to really stay for 8 hours or 10 hours just watching the system. This is the aim. This is not the aim of SRE. It's more about really regulating their work. So they need to choose their own workload, and they need to plan for it, and they need to be inspired and innovate, and also be part of the whole journey. So what's SLO? SLO is really the target or the dream that we want to really achieve, okay, by answering how well the system should behave, okay. Also, it's mainly focusing on the customer experience, okay, in order to track that the customer experience is not really, again, for some reason, getting lower, or customers are really frustrated or impacted by any problem. Some examples that we have there, like, for example, uptime of a specific service, 99.9 a month, okay? And this is, out of that, I can expect 43 minutes downtime per month. Or even I can say that the number of HTTP requests returned under 300 milliseconds. So it's really the request time that I'm going to respond, the response time per request, okay? And even I have here the 50% as a threshold. So this is my dream, that I want half of my returned request to be returned under 300 milliseconds. So if the customer are happy, definitely the SLO are being met, okay? But the other question that usually confuse people, what is the difference between SLA and SLO? Because we are always listening to SLA more than SLO, okay? And by the way, SLOs are never published to the customers, because this is the dream. This is really the super dream that we have in the team. But the SLA is really the agreement that we have and written with the customer. And typically, this is like an agreement to really guarantee that this service is gonna really deliver such a contract or such an agreement. And if it is not delivered, the expectation there that there will be penalties by the service provider. So SLA is more or less restrictive than SLO, and SLA is more published to the customers, because SLA after, not meeting the SLA means that we have a bigger problem rather than the SLO, okay? The bigger question, do we mean that if we meet, for example, the SLA, that the customers will be happy? No, it's not a must. Customers can be super frustrated and you meet your own SLA. So SLA is meant there to be like a guarantee for a specific agreement, okay, a typical guarantee for the agreement. And it is meant that beyond that SLA, we will have a bigger problem, and hence we need to have like penalties for not meeting those SLAs. But this does not really, it's not there to really track the customer experience as SLO. Is that enough? I mean, having SLO and SLA, is it enough? No, the answer is no. We need to have more beyond that, because the SLO and the SLA, those are just foundation, okay? And one of the things that I know that a lot of people would think of as SLA and SLO, about reliability, about availability, about resiliency, about response time, but it's not like that only. You can have SLA and SLO related to DevSecOps and related to DevOps, and it could be even related to audits, the number of audit records and the number of non-audited records, and the number of failures for trying to enforce or violate a specific policy. This is again an SLA that you can definitely define there. But the SLA and the SLO together, those are your basic foundation for the implementation of SRE and DevOps. So what do we need beyond that? We need consequences. What will happen if we don't meet SLO or if we don't meet the SLA? What are the consequences there? And that's why we need to have something that is called error budget, okay, or error rate as well. But let's first talk about what is SLI. SLI, this is the service level indicator, okay? And you can see from the name itself, it's focusing on a service. Yes, that's true. It can be business service. It can be distributed business service. It can be micro function. It can be micro service, and it can be an end-to-end business process. And that's why the service level indicator should, while defining the service level indicator, you should have all different teams and stakeholders involved there. And you should regularly as well review it in the definition itself, okay? Even at the end of each release and at the end of each postrum for each cycle while implementing your own software delivery, okay? In order to make sure that you don't need to really define new SLIs, or you need to redefine existing SLIs or SLOs or SLAs. So SLI is a service level indicator, an example, well-known example like the availability. And there are a lot of methodologies for defining or for calculating the availability, or not the availability, the SLI, I mean. The easiest one, it could be like, for example, good time over total time. So I can say, for example, availability of a service, it could be measured by the machine uptime, okay? And this is definitely intuitive for humans. It's more understandable and it's more easier to calculate, okay? But this will not really serve the need for microservices or for cloud native applications or for distributed solutions and services. And that's why we have a more sophisticated methodology for identifying the SLI itself by talking about good interaction or the ratio of the good interaction to the total interaction. Like, for example, the request per success request per response, or even 200 requests, the number of response that we receive a 200 HTTP 200 response versus the total number of requests that we received, and so on. So just to recap here, SLI need not to be availability. It can be application matrix, okay, defined matrix. It can be anything. It can be even assigned to rate limiting, for example, for an API or something. And based on that, you can define your own SLO and SLA. So once I say that this is the calculation that I'm gonna use for defining the availability SLI, I can from there talk about what are the target SLO or SLA, that I have for such a service. And usually it's not really, usually it's 99 point something or 99, around the 99, but nevertheless, you can face some of the services to really be delivered with an SLA or SLO around 90, okay? The thing here is that you need to calculate your allowed unreliable window. And this is again based on the business criticality, based on the service criticality, based on the dependency, based on the security, based on the complexity, based on a lot of things, and mainly the customer experience impact relative to that service. So you can see here that there is a window that is calculated per year and per quarter and per day. And from there, you can calculate your allowed downtime per percentage, okay? And also you can calculate from there the budget that the SRE team will be using for making tomorrow better, making our innovate and really think about really automation and innovating things, okay? So with meeting your SLO, okay, and your SLA, this means, that you definitely have more time to innovate, more time to make things better, more time to really implement a self-intelligent solution for your customers. Definitely one of the things that you need to consider, because I know if we talk to the business will always seek 100% availability or 100% SLI, okay? But this is not really a good, reliable manner, because again, you will have time to really downtime for releasing. Even if you are doing canary deployment or blue-green deployment, things can happen. And that's why 100% is a wrong reliable target for anything, okay? You need to consider that while planning, and you need to always consider that there will be a failure, and hence your SLA should consider such a failure as well as the SLO, because things can happen. Error budget. The error budget is definitely 1 minus your SLO, okay? And this is the budget that you are going to consume to make tomorrow better. This is the budget that you can utilize to invest and innovate in, for example, in robotics, in automation, like if we're talking about really building services, or even scalability across multiple infrastructure. So it's more for the SRE team, for your team, to focus on really making tomorrow better. So this is an example that, let's say that we have 99.9% SLO, uptime SLO. This means that after a 20 minutes outage, you still have 23 minutes of a budget remaining per month. So again, the SLO will include the outage, okay? Do you still hear me? Because I cannot see you. Yes, okay. Super. So again, the ultimate goal, because this is one of the things that the traditional DevOps and DevSecOps does not consider it, okay, is that I'm gonna really make things better, make tomorrow better, but this is based on the quality I'm delivering. I'm not gonna really have, for example, a service in production that is really failing every hour or every 10 hours, okay, even though that we are doing continuous integration and continuous delivery and continuous deployment, but I'm gonna have like task for really automating provisioning services, or task, for example, for implementing monitoring using events and really self-healing and all that stuff. It's not meant to do it like that. I mean, it's always driven by the data, and it's always driven by the quality data of the delivered services. So since we have, as I mentioned, the SLO, it's always either 100% minus, the error budget. It's either 100% minus the SLO or 1 minus the SLO. And based on that, you can calculate during a month, or during a cycle, or during a specific release or a quarter, what is the budget that you can really use to innovate inside your system. Okay, how reliable do you want to be? Definitely everyone is greedy to make things better, so it's always going to be more, okay? But the goal there is to balance things. So we need to balance error budget for engineering time, development and development speed and velocity, as well as money, because developers, they want to really move forward. They don't want to really focus on one single service for a long time. They don't want to use old framework. They want to really try things, okay? They want to, again, release things super fast, test things super fast. So the speed and the velocity of the development is really super important for them and for the project management. But as well, the error budget is super important for the overall system, because this is really giving me a gauge about really what is the quality of the service that I'm running in production, what is the quality of the service that I'm delivering to the customers, and also what is the money that I'm really wasting for doing, without a gain out of it. And that's why we have something that is called error budget policies. And the error budget policies are mainly talking about what will happen, or what do I do if I fail and exceed the budget, the error budget that was allocated by the SLA. And it must be visible improvement to the reliability. It's not really something that, again, it's not something that is, I'm going to add more resources, for example. No, this is not really visible to the reliability, okay? One of the actions or some of the examples, it could be until I meet the SLO, for example, no more new releases will be implemented, no more sprints focusing on new business services, but the sprints are going to focus more on the retro action items from the backlogs, rather than new stories, user stories, or new items or new services to implement. Or, for example, software delivery team must meet the SRE team daily to outline their improvement and to really test it and to show it and to demonstrate those improvements. So those are the policies, just examples, to the policies. But the main thing there is that, yes, it's good to really define SLI, SLO, and SLA, but without the error budget and the error budget policy, we are not really meeting anything. We are making the problem bigger in production, because today one service is bad, is not really reliable. Tomorrow it would be 2 services. After tomorrow it would be the 50% of the system, and it will not be reliable, and it will be more and more growing massively to consume more human resources, okay, without any value to neither to the customer nor to the business. So going back to the DevOps, let's see how error budgets really benefiting the DevOps and the DevSecOps. First of all, because we are talking about really defining a budget for the error, okay? This means that we are putting common incentive for both, for the SRE team or the DevOps engineers, as well as the development team. And we are defining a balance between innovation and freedom, as well as reliability. Yes, you are free to innovate as a developer. You are free to do whatever you want. Yes, but as long as your work is balanced with the reliability aspects and targets. Also, the development team is managing the risks themselves. They are not really throwing the code or the services to the ops team and the ops team or the DevOps engineer team, and they are doing it by themselves. No, the development team are involved, okay? And even one of the best practices that to involve them even in the operational activities, okay? Also, by the error budget, you are prohibiting to put unrealistic, reliable goals, okay? Because sometimes, as I mentioned, the product team or the requirement, while again doing requirement elicitation with the customers, they are targeting always 100%. Always everything, all the ellipses to be implemented. While when we sit and define the SLIs and the SLO and the SLA with the business users and with the stakeholders, we definitely from there define the error budget, and we definitely identify things that are not realistic, okay? Because it's definitely gonna be make the team not attracted, because they will not have the passion to really innovate in such an environment. Also, the self-policing, because again, as I mentioned, with the error budget, we are more involving the dev team into the process itself, into the culture of the DevOps itself. And it's a shared responsibility, okay? Developers or the dev team, they can eat their own error budget, but this means that they are going to stop in the innovation and in the development speed, and they are going to be impacted. It's not about really rebooting the service or adding more resources or getting people to watch the services and to watch for a specific error in the logs, or even building or using a software to watch such a logs. No, it's about shared responsibility. It's about really aligning seamlessly the development team or the developers into, and the business users, by the way, as well, into the maintenance phase and into the operational phase as well. So this is just to recap quickly. SLI, as I mentioned, measure the success, how successful enough your system, okay? And it's always by, or your service, and it's always by the matrix. And again, it's targeting matrix and thresholds. It's not meant mainly for the traditional matrix like latency, like availability, like uptime. It can be anything. It can be business, it can be security, and it can be any measure that you want to really assess the quality of your service and the reliability of your service into in production. SLO, this is the top line. As I mentioned, this is the target, this is the dream, this is what we want to really aim for and plan for, because this is gonna make definitely our customers' experience much better. SLA, this is the typical agreement and the typical contract that we have with the customers. And that's why you can see that the SLA is the SLO plus a specific margin plus consequences. Margin, this means that this is the margin that I can really adopt and the service can go on without really a red flag, okay? But this means that This means that we will have consequences, we will have impacts, we will have risks, okay? And that's why we publish SLA and we do not publish SLO. So SRE and the SLO and the SLI, as I mentioned, it's really targeting the three principles. So it's really transforming DevOps and DevSecOps from only focusing on the development and the operational, but as well considering the business aspect and the business stakeholders, and really measuring the whole life cycle and really avoiding any friction, okay? So it's really blending the agile concept inside the DevOps concept and really driving things by facts from production. This is the first principle. As I mentioned, we have three principles. The SRE needs to have service level agreement, SLO, and consequences. So first of all, yes, it's you will start by SLI, and you will need to really, it's not a one-time thing. And as you can see, you will see in the next slide, it's really an iterative things. And even we recommend to have it as a task inside each sprint, okay, to really re-review and revisit and identify the SLIs and SLOs and SLAs for your services and for your targets and requirements, and even in the requirement traceability matrix to include that as well. Nevertheless, you don't need to wait to have an SRE, okay, in order to have error budget and in order to define your own error budget policy. You can start and go ahead and have it there, because this can definitely prohibit growing the problem in production, okay. Also, it's gonna definitely keep customers from getting into a painful experience, and also it's gonna help you to implement, or it can be implemented, I mean, and help to be implementing the next principle, which is making tomorrow better based on what you have today, because everybody has a matrix measurement, a set of management. We all of us have either Prometheus and Grafana or Elastic and Kibana, whatever tool we are using, okay, but definitely we are gathering measurements and matrix, and definitely we have actions that we are doing today manually. So we can start SRE rather than waiting for bringing SRE team or hiring SRE team. So this is the process, okay, start by SLO and error budget and error budget policies. But again, it's an refinement and an iterative process. It's not really something, it's not one step process. It's always being revised and enhanced and refined. One of the best practices, part of what Google already have been enforcing for SRE, and this is heavily related to the first principle, and it's again heavily related to the frictions that we were talking about earlier. Avoid the toil, or try to eliminate toil. I mean, try to really eliminate any stressing over the team or the developers or the SRE team or the DevOps team, okay? This is not the case, because we want to definitely make them free to really innovate, okay, in their scale and target, okay? And that's why operating system in production, it's good, but you need to plan for it. It's not really a good practice to really start thinking about the operation and the maintenance while going to production or while facing the issue. And this is again related to design for failure, accept the failure, plan for it, and work with it normally. Also, don't think as SRE as a second, again, a secondary citizen, okay? They are first citizen, just like the software engineers and the software developers, okay, and even involve the developers in the process itself. And also make sure that you have at least 50% of the workload that is not related to operation, so that they can innovate. And that's why it is recommended that they need to deliver projects. It's not about really watching systems, and it's not about really again writing scripts to watch logs or reboot services or solutions, or even writing CI/CD pipeline. No, they need to have a project and deliver project. They need to be involved in the architecture and the design. They need to have automation, and they need to have as well authority on monitoring and iterating on monitoring, and they need to as well be involved in the game planning and in the retrospective action items. The second principle is to make things better. I mean, make tomorrow better. And because we want people to really make tomorrow better, we cannot really expect suffering people to make tomorrow better. And that's why I was talking about the toil as well earlier in the earlier principle. We need to make sure that they are capable of doing their job, and they are not stressed and not really suffering under the pain or the load in order to deliver their tasks. And that's why it should be a distributed effort, okay? And it should be a rotative effort between different team members as well. The shared responsibility, this is a super important principle in SRE and implementation for DevOps. SRE team cannot really make things work by themselves, okay? They don't have the magical wand to really fix unrealistic problems in production, okay? And they dumping everything on the SRE or the DevOps team will not really fix anything. It will make people frustrated. They will not make things better, and it will get worse by time even. Make sure that you have a balance between the development and the SRE, and that's why it is a good practice to definitely involve the development team in the operational activities. And one of it that they are today involved in defining the error budget, and they set their own targets, okay? And if they don't meet it, they already are involved in the implications and the consequences to it. And it's not only the responsibility of the SRE or the DevOps team. Regulate workload, as I mentioned, again, rotate things. So involve like 5% of the operational work to developers so that they are really into the process itself. And also make sure to track the SRE and the DevOps engineers, because if they are not delivering a complete project, we are not really, again, innovating and transforming. We're just moving in a systematic effort, okay? Because a lot of the customers think that DevOps are just CI/CD, and this is not like that, or monitoring. It's not like that. It's a transformational aspect. It's aiming towards really having a self-intelligent system, okay, at which we are really able to handle anything that can happen, any disaster, any catastrophe, and really either self action on it, okay, or even limit the consequences of such a failure or such a catastrophe. I mean, also one of the main things to consider, if every problem that you are facing in the system must go by the developer, okay, then there is a big problem also, okay. It's a balance thing. We are not really replacing DevOps engineers with developers, and this is not the ultimate goal. We want to really consider DevOps and operation and maintenance in the solution, in the architecture, We want to really, just like the principle of design for failure, accept the failure as a normal thing and work on it, okay? And also, we want to always be driven by data. So it's really, again, operation driven by data, maintenance driven by data. Our process itself, the software delivery, is driven by data. Also, the thing is that, as I mentioned, you cannot really think about reliability and operability and maintainability after launching the service. This is a catastrophe. This is super expensive, okay? And this is not really a good practice to think of. And that's why starting even in the requirements phase, and that's why I was talking about the architecture, not only the design, operability and maintainability needs to be considered there. And that's why SRE team needs to be involved in those sessions and on those phases. So they are really responsible for the resiliency of the architecture, of the system architecture, and also the consistency and the governance. They have super important goal there to make sure that things are consistently delivered, because this will make things easier, consistent from an experience to the customer aspect, and also from a regulatory aspect. If we're talking about security, if we're talking about any regulations that we need to meet, whether it's a security regulation or a business and industry regulations. Automation is important, yes. So anything that can be done manually can definitely be automated, okay? But make sure that you consider the error budget as a goal. I cannot go and automate, okay, and really make things or make tomorrow better, and I have a failure already. I'm already having a lot of problems in production. I'm not meeting my my SLOs and SLAs, and I'm always exceeding my error budget. In that case, I should focus on really making my system already meeting, or my service meeting the defined SLOs, okay, before moving towards automation or making things better. The last principle that we have today is give the ability for the SRE team to regulate their workload. So it's not about getting people to watch the system or writing bash scripts to watch unmonitored logs, or even it's not about really again, watching a specific process or rebooting services or systems. No, they need to be able to prioritize their own work and do it. And they need to as well push back, have the ability to push back to unrealistic practice. And that's why they need to be involved in every phase that we have in the software delivery. They are not an isolated silos to just watch the system to make sure that the service is up and running. They need to be involved and understand the business impact, the consequences, and also the implication of any service from a business aspect. I mean, if they don't meet a specific SLO. So again, the same picture that again DevOps is implemented by SRE as a class, okay? And in there we have the same 5 principles of the DevOps, and you can see that we are mapping the principles that we talked about earlier in the SRE, like the shared ownership. We are reducing silos because we are really blending the teams seamlessly together. We are accepting failure because we are defining error budgets, and we are defining the consequences of it and the policies as well for not meeting such error budget, or exceeding, I mean, such error budgets. And also the gradual changes here, as I mentioned, it's not meant only to talk about really sprints and releases and the agile. It's more about policies and about really driven by data more than planning and the business users only, by facts, I mean. Also leveraging tooling and automation, and definitely this is for the matrix, defining SLIs, and also monitoring and the SLOs and the SLAs, okay? And measuring everything, this is a super powerful thing, because again, reliability is not meant only about, or is not meant only for uptime and availability and latency. No, reliability is meant for everything, even for security regulations, even for principles that, or for services, for agreements, for things that I need to really tackle and watch. Okay, so it's not only about uptime and availability, it's about everything, and that's why we need to measure everything, and you are able to do that using as well application matrix, application-based matrix, not only the system matrix. So just to summarize quickly, again, define your SLIs. Those are the key matrix that you are going to use for your system. Define the SLOs and the SLAs. Those are the basic foundations to your DevOps and SRE. And the SLOs specify how good your service or system or microservice or microfunction need to be, and also use the error budget to really control the release velocity and to really balance between innovation and reliability. How to start? Again, start by defining the SLOs and the SLIs. Hire people to really think about software. It's not about really sysadmins. It's not about like that anymore. Okay, it's more about software engineers. Okay, again, the respect of the DevOps versus developers. This is a super important principle. And also provide regulatory feedback and a self-regulation for the SRE teams, okay, in order to always regularly maintain the SLO and the SLA and the SLI. It's not a rocket science. We can definitely start it. As I mentioned, we don't need to have an SRE to start implementing it, okay, SRE team, I mean. We can even start by one service, because again, it's a cultural transformation, okay? Another cultural transformation beyond even the traditional DevOps. Focus on one service, empower the team, build the story there, have a strong sponsorship and support. Also emphasize the philosophy behind the culture change that we are talking about here. Enhance and optimize the matrix measurement for the SLOs, and increment the process itself for more progress. And once you are in a stable state, definitely spread the love to other teams to show them the value of the SLI and the SLO and the whole SRE principles, and how it help in implementing the DevOps, but not in a traditional way, but more in transformational aspect. This is just the full scale, because I just give like a quick brief about how SRE is implementing DevOps and all that stuff. But definitely we have a lot of best practices for implementing SRE, or for having SRE implementing DevOps, I mean. And this is the full picture of it. Also, if you are interested in reading more about SRE and the implementation as a DevOps, we have a lot of books and blogs that are really empowering the idea. And with that, I'm not sure if we have any questions or anything to discuss. I know that we overrun.
Can you hear me, Rania?
Yep.
All right. Do we have any questions for Rania?
I have one.
Yeah? I'll repeat.
You repeat, okay. So you're talking about SLA, SLO, and SLE. But she also said not to publish them, whatever that means. My opinion or experience, you should publish them as part of the SLA to offer transparency to your customer or the business or whoever that is. Not only as an internal objective. And the other question that I
Well,
okay, sorry.
The question is, you mentioned SLO, SLA, SLI, but not publish them. And someone in the room asked, why not publish them? Because you could also offer transparency.
Yeah, actually, it's transparent. It's definitely for transparency. You can share the SLO, but this means that you are definitely putting a harder target and agreement for and hard expectation for the customers. Because again, SLO is the dream. You can meet it or not meet it, okay? But it does not mean that there would be definitely high implication on the customer, okay? It depends on the service itself. Usually the SLA is published because this is beyond it. Definitely the customer is impacted. So if you are not meeting the SLA, definitely the customer is not happy, okay? But it's not a must if you don't meet the SLO that the customer is not happy, okay? And it's not a must if you meet the SLA, the customer is not happy, okay? If you meet, the SLA, the customer is happy, the other way around. And that's why most probably you don't really publish the SLO, but more the SLA, while you test and target the SLO more. And that's why the error budget is based on the SLO. So if you don't really meet the SLO, this is a failure in the planning itself and in the implementation. I hope that this answered the question, or I got it correctly.
Answers my question. I'm not sure how you agree.
That's
fair.
That's a whole different topic.
I don't know if you understood, but the person in the room said it answers the question, but he's not sure if he agrees. Unfortunately, we have another speaker, so there's not much time left. Rania, how can I reach you if people have follow-up questions?
Over email or over chat? Definitely.
Yeah, or email or Twitter or.
Yeah, or LinkedIn or Twitter or I mean anything. I mean, I'm gonna definitely respond.
We've published that on the Meetup page, right? Yeah, so
Yep.
LinkedIn is on the Meetup page, so if you want to reach out to Rania, LinkedIn.
For more discussions.
Yeah. All right. Thank you again.
Thank you.
Yeah, I'll take care of it.
You take care of the stream and
Rania, thank you so much. Thank you so much.
Thomas.
Let people have a break first.
Oh yeah. There's drinks here. Drink, Coke, a beer.
Grab something to drink while we switch over.
Can you make this full screen? Too much tech everywhere. Get it away. Am I already live? Are we live? Live, like on YouTube live. Yeah? We're back from the break? That's basically what I'm asking. One important thing to make it a little bit easier for everyone. I can hear myself somewhere, so we're definitely live. Well, please don't mute me. But then you're going to mute the music. No, don't kill the music. Oh, you don't. Yeah, apparently we need 3 laptops in order to do this, so that's how fucking serious it is. So this is Kahoot. Does anyone know Kahoot? Awesome. Let me just get out my speaker notes because I prepared a bunch of things in the last 5 minutes. Just have to find my notes app, which is hiding. There we go. So just before we... That would actually help a lot, yeah. I need 2, actually. Just now. So I want to do a quick survey before we continue. So I want to ask who would consider themselves a developer or have a dev role here? And who is more on the ops SRE side of things, by show of hands? And who considers himself something completely different? Nice. Oh, good to know. But I'm just wondering. So, what do you do if it's not dev or ops? Just an intern. Well, awesome. Good to have you. And then question number 2: who has been to a DevOps stage before? Nice. That's what we like to see. Because, yeah, you're welcome, man. So the thing is, we're of course doing this meetup, but it's also, yeah, what we're also do, or what? Well, I'm not organizing Devops Eindhoven per se, but Daniel over there, Joep, Floor, Jos, Helmar, so many people. They all are all organizing an event that's going to take place next month. It's going to be at this location as well, so you already know how to get here. So now all you need is a ticket, right? So this is your chance to get a free ticket. But you might wonder, why should I even join a DevOps stage, right? Well, there's many reasons, but one of them is that we're going to have our own barbecue. It's in October, but yeah, thanks to this kind of weather, it'll probably be 30 degrees in October as well. We have a special brewed beer called Devops. Haha, very fun. And then I just went to the schedule to check out a couple of talks, and I just wanted to mention them here. So there's one about managing technical debt at scale. Well, no one here has technical debt, right? So we don't have to go visit that talk. Then there's one named "This is Fine, Dog. It's Not Fine." That could be interesting to go to. And just saw for myself, like Suzanne Daniels, who's a dev role for Spotify for the Backstage projects, is coming as well to talk about like the developer experience tool they're making Backstage. So now I have a good reason to go as well. Yeah, exactly right. Did everyone get a chance to join? Do you want to join? Yes. Then we're gonna start. So these questions were all created by me this afternoon while I had like 10 minutes. So some of the questions might be quite stupid. And if you're a developer, don't be offended by anything it says here. Ooh. Uh-oh. Daniel. Yeah. Come on, 5 seconds. I've got this. It's a great question.
Someone actually what? Nice. That's my bird here. Yeah.
Ah, good start, everyone.
Do you want to tell us about the first year?
No, not now. I'm gonna click next. No, it's not auto. I'll take care of that. Hey, good job. Whoever you are, we'll find out in the end. Ah, that's a spoiler alert.
Oh, that is with
No.
every slide.
Oh no, is it?
Question 3.
Which
Yeah.
year did we?
Did we serve the first DevOps at Devops Days Amsterdam? This is the bottle. It's right there.
It says it right on the ball.
Yeah.
I'm the little.
Oh.
Big.
Oh. Few people know. Wow. Hey, you. Do you need a free ticket?
I'll do a Kahoot if I know.
No.
So developers are. It was just a joke. But, oh, the good thing is the right answer is probably not what you think. Hopefully not what you think. Yes, very good.
I'm going to miss some deadlines at work.
No, you're not. Easy question. Yeah, according to the book Accelerate, which 4 metrics should you measure?
Oh my god.
You cannot see it? I'm not going to read those out. If you can't see it, you have to get closer. Is it on your phone if you were? No. No.
If it's the red one, I don't believe it.
Spoiler.
Are we going to wait for 30 seconds, Thomas?
I don't know. I guess so. It's because it takes so long to actually read all the options, right? So.
So you actually had to read.
You could.
All right.
Go, you got 20 seconds.
Let's see. I'll just start from the blue one. Total weight of team, beard length, pants, and pizza slices per sprint. The yellow one is the number of blameful postmortems. Your velocity, number of emails sent out per stand-up. WTF BBQ. The last one, deployment frequency, lead time for changes, mean time to repair, change failure rate.
Red one is good. It's like just rule that.
Exactly. Ooh. Oh, Dimitri, you're doing well. Mark is right on his tail, though. This is going to be interesting. And Joop has dropped out, I think. I hope. When are you finished on your DevOps journey? This is the band journey. It's nothing to do with journey. It's once you've successfully implemented safe agile framework. When PagerDuty wakes you up 12 times per night. Never is about continuous improvement. When my boss tells me it's done.
The red one is a trick question. We're never done with minutes.
Can I ask, what is
If you don't know, it's fine. Keep it that way. Yes. Yeah, you. Yeah. He works at Jumbo, so we are hiring.
I'm going to pick like
We are hiring.
front-end development.
Well, you're already doing so.
Look, I have the highest answer.
Hey, good job, Floor.
To refresh this, or
To use a microservice architecture, I must strive to have. Java, Kubernetes, decoupled services, very expensive consultants.
that's one. Just clearly multiple.
There, oh no, there's only one right answer in here. Yes, good job.
Really good question.
Thank you. I came up with it myself. Hey, Dimitri is on fire. Mark still right on his tail. Let's see what happens. Any organization that designs a system will produce a design whose structure, there's missing a part of the code, which reflects the communication patterns of that organization. Whose law is this? Moore's law, Newton's second law of physics,
It's cool.
Murphy's law, or Conway's law?
Right.
Yeah, just read, I am the law. Hey, we have some smart people here today. Even with half the question missing, you still get it right. That's very impressive. The CAMS acronym stands for Culture, Autonomy, Mastery, and Scrum. Culture, Automation, Measurement, and Sharing. Cats, ants, moths, and swordfish. Cheese, anchovies, mustard, and sugar. So 2 of these are definitely wrong. Because there's Scrum in it. Hey. That's going. Where will DevOps Days Eindhoven take place this year? High-Tech Campus, the Philips Stadion Eindhoven, Van de Valk, P4, lang parkeren at Eindhoven Airport. Who picked the green one? Honestly. I need to go back and watch the logs of who picked that one. True or false? Double points. I want to win a ticket to DevOps Days Eindhoven. True or false? Well, if you don't want it, you can just click false, and then someone else will get double points. See, someone actually doesn't want a ticket. All right. Well, then I guess we will have a winner on 3rd place. Up. There you are, man. Number 2, Mark. And the winner is then Dimitri. Congratulations, man. You get a free ticket. You go talk to Floor. She just volunteered to get you the free ticket code. So let me just quickly think about how I'm gonna do this, because I actually have to go back into this. So so please just ignore my failure of putting slides in order. I've never done a presentation before. Let's see. So just ignore it. You're not going to win anything. But if I finally get there, if you didn't win, you still have a chance to get 25% discount, but only to the first 20 people. So that's about 20 attendees. So no, organizers are not allowed to participate.
We already have discount code.
So I think everyone has a picture.
Yeah.
Everyone has a ticket. Good. Then my short show is over.
Yay!
Time for the last speaker. Mr. Streamy, how do I get out of here?
Yeah, okay. You gotta buy a ticket first and then you can leave.
Yes. I already have it. I was the first one to get a ticket.
All right, phone.
Good? Perfect. Okay.
There we go. Jos, you want to do the introductions?
Excellent introductions.
Yeah. Very happy to introduce the architect Om.
Yes, yes, good.
Been very interested to talk about chaos engineering. I'm looking forward to it. So please take it away.
Thank you.
We've already demonstrated the chaos part.
So now the engineering, yes. Okay, good. So yeah, already pretty late. So I'm the one who's standing between you and your sweet dreams. So I will try to keep it short. All right. So what I'm going to talk about is why breaking things should be practiced. So I work at AWS as solution architect. So that means that I'm going to show how to apply chaos engineering on the workloads running on AWS. Right. So we are going to talk about some of the services, right? Not many, just one, right? And how to use that service, right? But before going into the detail, all right, just check what's happening here, right? And we will start our talk from here. So there is a man, and that man is walking, and at some point, that man decide that okay, let's cross the fence, right? Probably it's easier way to pass the road. And what happens? And in technical world, we say cascading failure, right? And you all must have experienced something similar, right? While working in a team, maybe you have done RM-RFB. I have done in my early stage of my career. I have done it like for the acceptance environment. It was getting ready for demo. I had pseudo privilege and history, and there was nothing. Right, so and this can happen, right? This happens everywhere, and what it does, it could be a simple code change, it could be a simple service update or a SQL command update in the database, right? And what it does, that it brings your whole system down, right? And today's talk, this is what we are going to talk about, right? How to prevent such failures, how to prevent the failures which are like not known, which are unpredictable, basically. So this is not a distributed system, right? It says distributed system is complex, but first of all, let's focus on simple system, right? Simple system running in isolated environment can be very easy to run, right? It can run without any failures. You can put all the monitoring there, right? There is no problem, right? But a distributed system can be really complex, where dozens and hundreds of services are running together, right? And so a couple of 100,000 of requests or millions of requests are coming, right? And you can think about the permutations of failure that can happen in a distributed environment, right? And even the simple systems can be complex, right? You can see the demonstration of simple system here, right? This can be also complex if I can go into the details. So there are three components, so three distributed components here, so not connected with each other or not on the single machine. Right, client is sending the message to network. Network is forwarding that to server. Server is doing some validation, updating the state, putting the reply, and network is forwarding that reply, and client is also validating the reply, right, and then updating some state, right. So if we go into the detail of all these components, so this can be also complex. So if this is complex, then think about these ones, right. And this is basically self-discovery diagram of the Amazon system, Twitter, and Netflix, right, where a couple of hundreds of microservices are connected together, right, and making the whole system work together, right. And as a job of software engineers who are working there, their job is to make sure that all these functions, all these services are working together well, right. They need to write code in such a way that it can handle the failure on the client side, it can failure in network, it can handle the failure on server side. So code basically what is written there, 99% of the time, there is no fixed number, but code is basically written in such a way that it can handle the failures. And this is microservices architecture, and most of the organizations in current time either have adopted microservices or in the journey to adopt the microservices or thinking of adopting the microservices architecture. Right. So we know distributed systems are complex, right? But why it is complex? You have seen a little bit, but the reason of complexity is that in distributed system, there are multiple components are often running on different machines, and especially in the era of cloud, right? So you don't know where your different components are running. Your application service can be somewhere else, database can be somewhere else, or maybe even the part of application can be running on multiple servers. And there is variation in implementation. So that means that one of the service can be can have a requirement of hard real time, right? It has to respond in a couple of milliseconds, but one can be just batch processing service, right? One can be implemented using container, or one can be in serverless, or maybe one is still running on VM, right? EC2 instance in terms of AWS, right? And it can be written in different programming language, could be Java, TypeScript, or Go. So there is a different variation of implementation. And what happens that that complexity is basically leading to difficulty in predicting the failure, right? So our job in the chaos engineering, when we apply the chaos engineering principle, the goal is predicting the failure, finding the failure before it becomes outages, right? And as the complexity grows, so predicting those failures, that becomes harder and harder, right? And we do traditional testing, right? But traditional testing is not enough, right? And I'm not saying that it is not required. It is required. It tests the known conditions, right? But it cannot it is not enough for complex production environment, right? It cannot find it cannot test for the unknown condition, right? For example, think about different situation. There can be a situation that there is a database failover, right? If you have knowledge about RDS, right, which is a relational database service in AWS, and you have implemented multi-AG settings, what can happen that it can fail over automatically from from, let's say, primary to secondary or replica, right? In certain situations, right? You cannot really test those, right? And especially in those environments, in dynamic environment where auto scaling groups are involved, right? It is automatically creating, deleting servers without your knowledge, right? So that's where we need to think about chaos engineering part, right? Which is one step above than the traditional testing, right? And I can give you example that disk running out of space, right? So what happens when disk is running out of space? It looks like this, right? And it goes like this. And you can imagine if you have ever encountered this issue, right? Debugging a system where disk is running out of space, right? It is not an easy task, right? And there can be lot of similar things which is happening on production environment which you cannot catch in traditional testing, right? So that's where chaos engineering is coming, all right? What is if we go by definition, right? What is chaos engineering? So it is one line definition that it is identifying the failures in your production environment before it becomes outage, right? And in some of mission critical system, those outages can be very costly, and we have data from different companies that those company had at cost of few hundred million or millions of dollar because of outages, right? And what we do in chaos engineering, that we break things on purpose. We break it because we want to test the resiliency of system. We see that if we break something on production, how resilient is our system, right? And why we do it, right? So as it is written there, that improve the resilience of system and of course performance, and uncover some hidden issues. So some of the issues probably you haven't thought of, right, during the analysis phase or during the development phase, right? So by breaking the things on purpose, you uncover those issues and find and expose the blind spots. So where you implement monitoring, observability, alarms, and it could be that there should be something more which should be monitored, which should be there should be alarm on, right? So these are the reasons we basically do chaos engineering, right? And by now, I think we have some understanding that why chaos engineering is important. So why not everyone is doing it, right? Of course, there are a lot of companies doing it. There are a lot of companies who has intention to do it. So why it is challenging? It is challenging because of some reason that there are a lot of open source tools available to do chaos engineering, right? The challenge is bringing those tools together and get it working, right? You have to cook some script at your home yourself, or you have to write some program yourself, right, before you can really start doing chaos engineering, right? Other challenge is with the library compatibility, right? Maybe you are running Windows application, the chaos engineering libraries that is not compatible, right? Or there can be a lot of other reasons, limitation in support, right? And because of that, you cannot do good chaos engineering. Safety, and this is one of the very important part of chaos engineering, right? If you often do, or we often do chaos engineering on the production environment, if there is not a proper safeguard, then that chaos engineering experiment can become outages, right? It can really break, it can get your system down, right? So that's why we need to have safeguard that in what situation we need to stop that experiment. And difficult to reproduce real world events. So during chaos engineering, we just don't want to do the testing, but we want to simulate the real failures. We want to produce the failures at software side, hardware side, network side, and even at the service control plane side in case of cloud. So these are a couple of challenges, and that's where I think I'm not sure if you know about fault injection simulator. It's a service we have launched 2 years ago, maybe little more. So why we have created this service to solve the challenges which I have described in the previous slide. So one of the tenets of this service is it should be easy to get started, right? You can go into AWS console, or you can use CLI, right? Like you use any other AWS services, you can use this service in the same fashion. It tests the real world conditions. So by saying the real world condition, this is the first service from AWS which gives our customer access to service control plan indirectly. So that means that if you run the experiment from here, so so faults are really happening at the service control plan level. So it is really creating the fault there. Before this service, none of our customer didn't have access to service control plan level. They only had access to data plan, right? And safeguards. So we have implemented safeguards using two mechanisms. Using CloudWatch Alarm. If you know about CloudWatch, it's a logging service, and alarm is if something goes wrong, it goes off. And IAM role. IAM role is policy management. So where you define that, okay, what this experiment can do. You can define that, okay, this experiment can only touch particular application, or this application can only touch EC2 instances, not the database, right? So by applying IAM role and CloudWatch Alarm, you can apply safeguards. So very high level, going into what are the components. So it starts with experiment templates where you put everything together, right? Actions, targets. Action is what you want to do. Target where you want to apply those actions, right? And experiment is you will see it later what it is. So very simple example of actions. So you can see that stop instance, terminate instance, and you can decide the time you want to run it for 10 minutes, 1 minute, how you want to run it. Like here it is defined like start after this action. So you can define that two actions should be running in sequence or in parallel. It's up to you how you want to define those actions, right? For those actions, you need targets, right? And here the example of targets are some EC2 instances, and you can select, you can choose that, okay, which target you want to run those actions on, right? You can very simple selection strategy in AWS is tag, right? So with the tag, you can select some instance or all instance, or you can choose some random instance with some advanced filter criteria. What you see here, like which availability zone it is, right? Or which what is the state, right? With this filter criteria, you can create an experiment where you bring down all your EC2 instances running in one availability zone, and you can simulate like kind of availability zone failure. Experiment template, what you have everything putting together. So that's where you put your configuration, or put your all the details about what you want to do it chaos engineering, right? Name, description, and there are IAM roles and stop conditions running as safeguard, and targets and actions. And different experiment template can look different. Here you can see the differences, that how actions and how targets are selected. Yeah, it's like sequence, parallel, one specific EC2 instances, or all EC2 instances, right? You can decide how you want to do it. So experiment, what is experiment, right? So just to compare it with OOPS analogy, right? Experiment template is class, so experiment is object, right? So it is snapshot of experiment template. So you choose experiment template and you say, okay, run experiment, and then you have experiment created, right? There are some obvious attributes which are not very relevant, but yeah, it's there. So at this moment, what we do, we support 4 services, and more are coming, right? We support EC2 instances, we support RDS, EKS. EKS is a Kubernetes service, managed Kubernetes service, and ECS. And we support some system manager actions. System manager is a way to run command on your EC2 machine, like some operating system level command, CPU stress, or memory pressure, those kind of things, and some native fault injection simulator native actions, which are basically API throttling, or API error, or API not available, which is happening on service control plan level, right? And these are the actions for supported fault injection at this moment, right? And more are coming, of course. So with that, this is what I had to show, and I want to show something on the console. Right. Yeah, live demo. So I hope, let's see, it works. If not, then we go to bed, right? We start driving, and then. So, okay. I want to switch. I hope. Yeah. No, I think it will be 10 minutes. So, yeah. So what you see, let me see. Yeah, my session is good. So what I have done to save some time, right? I have already created some infrastructure, right? And I'm only going to show which is relevant to chaos engineering, right? So if you want to start with chaos engineering, right, what you need to do, go and AWS FIS, which stands for like fault injection simulator. Right, I have created what you see here, that experiment and experiment templates. I have created some experiment templates already with CloudFormation, our infrastructure as code tool. But I will go into one of these later. But let's create one experiment template from scratch. So what is going to be the first experiment? What we want to do, that we want to stop one EC2 instance. That is a very simple fault, right? You have an application running, maybe on one EC2 instance, you want to stop and see, yeah, what happens to your application, right? So I cannot type faster, so it will take some time. So, and then add action. And here you can see all the actions type which are available by default, right? You can choose, right? There are as I have explained before, so there are different actions type, and which you can find it like AWS colon service name. So what I'm going to do, I'm going to choose simple one, stop instance, and what I'm going to say here, that just run it for 1 minute, and you decide that how much time you want to keep these experiment running. You can do it like 10 minutes, depending on what is your use case, right? So this is what you have to do, right, for experiment. And and then actions, you have defined the actions, right? So now we need to select a target. I'm going to select a very specific target, which is instance 0 here. You can select based on filters, tags, and different parameters. That's up to you. Then save, and I think, and then of course I'm role, right? Because this I'm role will give the access permission. So as I'm creating this experiment without stop condition, without safeguard, it is asking that, okay, you are creating something disruptive, right? You're okay with this? Yes, I'm okay with this. And the experiment template is created. And then what we need to do, just start the experiment. And again, it is saying that, okay, you are going to do something disruptive. So do you confirm? Yes, I do. And this experiment is started, right? And so the target is EC2 instance. EC2, if someone doesn't know, it is a virtual machine on AWS, right? We have, yeah, it has already, you see that we have selected this target instance 0, right? It is stopping now, right? So what it is doing that, and you can see here on this console, that the status here will change, right? So there is a state of experiment which is saying running. It will stay in running state for 1 minute because we have defined that, okay, run this experiment for 1 minute, and after that it will be finished. And once this will be finished, I think 1 minute is not a long time, we can wait. So what you will see, that once this instance is stopped, it will automatically come into the running state. So that means that experiment is only impacting the service, right, while it is running. Once it is stopped, once it is finished, your service will come into the original state, right? So here, in this case, it is stopped, and yeah, you see soon. Let me see. Oh, no. It will, yeah, it's completed, and here you will see that it is running again, right? Because experiment is finished and it is coming to the original state. But this is not a very good example of creating the experiment. So what we need to have, we should have some stop condition, right? And how we implement the stop condition is we implement it using CloudWatch alarm. So what I'm going to do, I'm going to update the same experiment template which I have created, and what I need to update is action, right? In the action, in the action, what I'm going to do first, I'm going to increase this time so that it has some time to trigger the alarm, right? Otherwise, it will be finished before triggering the alarm. So this is I have increased this time to 3 minutes, and now what I'm going to do, choose a CloudWatch alarm, and this CloudWatch alarm I have already created, right? And it is saying that network abnormal. But what it will do, that when this alarm goes off, this experiment will be stopped. So I've updated it, and I'm going to start this experiment. And this time you have noticed that it doesn't ask for confirmation that you're creating something disruptive, because there was some stop condition. So I'm going to start this. It is the same instance again. And let's see if it is. You should see it soon. It's running, and it is stopping. Right. What I'm going to do, yeah, of course, to save some time, I'm going to manually kick off the alarm. So for that, I have a. Let me see. So this is a simple command line. What it is going to do, it is saying that, okay, set alarm state to alarm for this network abnormal. Before I do that, let me see that if it is really stopped, because then we are going to see that, okay, if it is stopped, so just wait for some seconds. Taking some more time. I need to wait before it is stopped. Otherwise, yeah, I'm interrupting its state. Yeah, it is stopped, and oh, it's okay. Okay, thank you. So what I'm going to do, let's see. Yeah, so you see what I'm going to do. So here you see that there is a CloudWatch console, and you will see. Let me reload. That alarm is in alarm state. Right, this specific alarm it is kicked off, and what it is going to do, first look at here, it has stopped this experiment. Right, this experiment was supposed to run for 3 minutes, but this alarm kicked off, stopped it, right, because something was going wrong in the application, and it was stopped. And then you see that it has rolled back the state of the service, bringing the application back to its original state. Right, so this is the way you can. This is a very simple example of how you can create some experiment. How you can apply some safeguard, but there are other examples. What you can do here. Let me show you. Is here experiment templates. So what you can do also, just for an example, I'm going to show you this one, and I'm going to connect this with Session Manager. If you don't know about Session Manager, it is basically accessing the console of your virtual machine directly from AWS console. So you can also do OS level experiment. You can simulate the failure at OS level, and how you can do that? You can do that using System Manager, and as I have explained before, that System Manager is a way to run command directly inside the VM and do CPU and memory stress. So what you see here is this is a System Manager command which is saying that, okay, run CPU stress for 2 minutes and see the impact of this experiment, right? And by doing this experiment, you test the performance of some performance of your system. You can choose the target, one or multiple, depending on what your experiment hypothesis look like. So what I'm going to do simply, and this is going to be the last experiment. I'm not going to show everyone, all right, each of the experiments. Start, and what you can see here is, so you will see that CPU is going up, all right, and why I'm showing this experiment, because it gives you like a building block, right, that how you want to design your resiliency testing, right? So you can combine multiple type of experiment templates, multiple type of experiment, and you can build a test scenario, or build a, let's say, chaos engineering experiment, which gives you more resilient system on in production environment. So this is it. You can also do, you can see the example like terminate EKS node, right? Or you can terminate the container instances. So there are many examples what you can do, but you can cook all those things by yourself if you have access to AWS console, right? AWS account. It's very easy to start with, right? So this is what I had to show, right? I hope I didn't take a lot of time, all right? So if you have any question, all right, so please go ahead. Yes.